Okay, basically you can define the software. So in the software engineering process, you can define software as a set of instructions. Earlier days, like we used to do like that, set of instructions. Okay, so don't focus on the singular thing. Like if you don't know about that, just think about the English definition, which I have highlighted here.
Okay.
Here, software is a set of instructions. Not just that, in this stage, when you're drawing, you define software not just as a set of instruction, it is related data structures and related documentation. Right? Set of instructions, something in between the computer and you, something in between the computer hardware and user, basically. So that is true, right? It is working as intermediary between you and the computer. But we can define that formally as a set of instructions to the computer, plus the related data structures. Means with the software, there should be some data structures. Right? That is how the related data related to the software are stored. Right? For example, okay, you have shapes. Insert, when you go to the insert menu in Word, you have shapes. But these shapes are stored. These shapes are predefined and stored. Right? So those are stored as data structures. Understood why data structures are there? Because instruction, like these are the instruction. When you go to home menu, insert menu, there are commands, instructions running, and you can print it, you can take a new file. Likewise, there are a lot of commands. So these commands actually runs instructions. But to run this instruction, you need data structures too. The data structures means already stored data about data related to this software, and related documentation means it guides us how to use this. For an example, if you move on top of this, it says insert picture. Can you see there's a small tooltip text? When you move on top of some icon, when you move some top of some icon, it says what it's going to do, right? It says what it's going to do. There will be a tooltip text, right? And not only that, so when you go to help menu, we can get the help. Help is also a documentation. It guides us how to use this software. Right? That is why software is not just instructions. We can say it is instruction plus the related data structures plus documentation. All together, we can call it a software. Right?
Okay.
Okay. I'll don't worry, no need to write down that. But if you need like some special things, you can just note down. I'll provide this instruction. I'll remove the single medium one and provide you the English medium one. Right? So if you need single medium one, I can still provide, but I think that you cannot understand this, right? Yeah.
I can't read it, but I understand when somebody speaks it.
Yeah, right. Yeah, you can just refer to this part because until I have created this note as a common note for both medium students, but you can just use the English medium one since it's convenient to you, right? Okay, then let me tell why this software called software engineering. So why there is a need for software engineering? Engineering is not something simple, right? Engineering is something like, in any country, engineers are some special skilled people. Special skilled set of people. It's not just people, they are skilled set of people. So why? Because they need planning skills, they need creativity, building skills, thinking skills, cognitive skills. So different type of skills are needed to become an engineer. It's not easy. Simply, it's not easy. Why software engineering is needed rather than building the software? So you can build a software, right? Building the software is easy. So when you open this, after installing this, ideally, if you open this, you can start coding immediately. So for an example, this is the IDE. Have you installed that after downloading or not yet?
I'm following a tutorial on a website on how to download a Python.
No, that doesn't require to that. So if you can share the screen, I can tell you how to do that. So just share the screen. I'll tell you. It's simple.
Okay, let me show you.
Just share the entire screen then.
Okay.
I have enabled sharing.
Mm,
You can go to the green color button. It mentions share in the middle. So then
yeah.
there will be a window prompting. Different windows will be there. You can just select stream from that and then click on the, right, okay, that's it.
Okay.
Okay.
Yeah.
That
I'm
is the
over here.
particular specific window. Without selecting the specific window, can you try to share the entire screen? The reason is then I'll not be able to guide after. Yes, just try to share. Don't select any specific screen. So in first option is I think screen or something, screen or desktop or something.
Oh, okay.
Yeah,
I got it.
just do that. All right, okay. Then the end. Okay, that's right. So then the
This is
entire.
what I have.
Yeah, you have downloaded and installed this. That's good.
Okay.
That is after the installation, yes. So let me show how to run this then. So just you can just go to the ideally, that one. And whatever the commands you need, you can run ideally itself. That is specialty. So for an example, if you type there 5 plus 6, 5 plus 6. No. Just type 5 in number 5. Number 5. Just
Like
erase
this.
file.
Mm-hmm.
Erase file. Just type number 5 there. No. Just the digit 5.
File.
Yeah,
What
5.
digit?
Yeah, 5. 1, 2, 3, 4, 5. Just 5. Okay, any number, right? Okay, plus mark. Okay, some number, some other number. Type something else. Okay, then press enter, and it will calculate for you. So that much
Oh.
of simple, right? It's very simple. So when you provide instruction, it does the calculations for calculations. But for printing and all, you can see there's an instruction here. You can use that print.
So
Then within bracket, within quotation, within double quotation, you can just print something, hello world or something. Just then just close it and enter. Then that will be printed.
oh,
That is
okay.
very simple. So this is how you run a code in ideally. But if you want to run it as a small software or a set of instruction which is saved, you can go to the file new. Just go to
File.
IDE, select file and new file. So then you can start typing, maybe just type print hello world.
Okay.
Okay, then just go to file and save it. Save as or save. Then you can save any name. You can do like ABC, something like, then .py. Okay. So you can see the py is indicated there. Hello world.py in the title bar. Can you see? Yeah, even yes.
So it should be. Oh, here it is.
Yeah, it says py. So that is the extension. Okay, just close it, and after doing that, you can either double click or you can just go to run and run module. Run module. That's that one. Or F5 is the shortcut, and it will be run.
Okay.
This is how you run as a new file, right? So those are the two ways of running the Python files. Easy, right? You are using Ubuntu, right? Ubuntu or
Yeah, Ubuntu.
Ubuntu, right? Okay. So let me share my one. So now you know. So basically, how to run an instruction. Anyway, so this can be possible, right? You can go and code. You can go then code there and start building a software, but so that is there. But even though that method is there is something called engineering. The reason is this. So anyway, using computers, we convert data into information. So that is called abstract model of information. We take data for fundamental things, and then we can convert that to information. Just let me show some example. Okay, this is taking Excel file. Just showing small example. And let's say even a character to computer is data. Let's do small thing. I'm going to change the column width to, okay, great. Okay, let me do small thing. I'm going to write a matrix there. Do you know matrix in maths?
Metrics?
Matrices, have you learned matrices in maths? If not, don't
Yeah.
worry. Yeah, if not, don't worry. I'm just putting zeros and ones. Let's see. I'm just putting zeros and ones, right? So initially, I'm going to fill all these slots here. Let's see, here to here. I'm going to fill it with zeros. Okay. So just think this as a LED set of LEDs. This is representing one LED bulb. This is another LED bulb. How many LED bulbs together?
49. 40.
Here actually is 6. Here you have 7. 6 into 7 is 42, right?
Mm-hmm.
If you count, yeah, 42. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Likewise, there will be 42.
42.
Yeah. If I erase this, now it is 36, right? Here 6 by 6. This
Yes.
side 6, this side 6. Okay. This is 36. Okay, let's see. Let me show how the computer display a character. See, just use this kind of thing. Okay, it's changing some digits. Think that these are LED bulbs. Then it's lighting up some LED bulbs. Let's light up these using some color maybe. Let's use a color. Okay, so then if you zoom out, actually you can see character C, right? This looks
Yes.
like character C. This looks like character C. Let me use some dark color. So then it's clear. If I zoom out this, it is character C. So this is what actually happening in the screen. Now you can see this is the small one is character C. This is what happening in the screen. It will take small dots called pixels, and by coloring up the pixels, it will display characters. Got my point?
Yeah.
If not, tell me, right? Did you understand what's happening? This is how you display a character in the screen. So why you can see all these things because of this process. For an example, you have printed hello world there now. Hello. Okay, let's take this A, letter A. If I capture a photo of this, I'm taking a photo of this, and if I zoom this photo, if I zoom this one, you can see it is just a set of dots which are colored. Can you see?
Yeah, I can see.
It's just a set of dots which are colored. So that is what happening inside the computer. We can see that as a character, but actually it's not. Actually, it is set of dots, right? Okay, actually it is set of dots. So that is what I want to tell. Even a photo is created such a way, right? Video is created by playing such photos. We'll learn that in future. Anyway, everything happened from the fundamental unit, and then it will be processed carefully. Process means arranged, mathematical calculation, no arrangement, anything. Then information is produced. Do you know what is the most valuable resource in the world?
Information?
That is information, for sure. So that is why if you search top 10 richest people in the world, top 10 richest in the world. I don't know the current statistics because it's changing day by day, right? So you can see Jeff Bezos, who owns Amazon, Bill Gates, who owns Microsoft, right? So then when it comes to Larry Page, Larry Ellison, Sergey Brin, Google, Oracle, these companies, right? So only some changes are there. Gautam Adani, Mukesh Ambani, these are some people, right? So, but the thing is, like if you take, this is Forbes. So according to Forbes, it's who are the top 10? Oh, here. Musk is there. Musk from Tesla, SpaceX, a technological company, again using information. Jeff Bezos, Amazon, again using information. Bill Gates, Microsoft, again information. And then 2 Indians are there, right? So, but they are diversified. They are in different industries. Larry Ellison from software, again from information. Larry Page, software, Google. Sergey Brin from Google. Mark Zuckerberg from Facebook. So those are the people. So if you recognize all these people, they are using information. So what Zuckerberg is selling, it's information. So again, what Microsoft, Bill Gates is selling, information, right? So that is the world's most valuable economic resource. Right? Data are raw facts, data are basic things, but information, processed, meaningful things, which it's valuable, useful in decision making, and it is an action motivator too. We are motivated to do some action. Let's say if I inform you by sending an email, so today there will be a class at this time. That is information. That is an action motivator. You will think, this time I need to join. Right? Okay. So if anything unclear, please tell me. Okay. So information is the most valuable resource. Actually, software working with this information. Therefore, it needs engineering. Why? Because let's say if you knew something about this COVID-19 virus, and if you have collected data and if you know some information, how to heal, how to properly heal that, definitely you will become a billionaire. Because you have that information with you, right? Earlier, no one had that. But if you had that by that time, by 2019, if you had proper information, how to produce a medicine to heal this, definitely you will become a billionaire. And that is the thing. So that is how valuable information is. And so fail to process information properly. Software actually working with information, but that is why we need engineering process. Right? Here, software works with information. It is one of the most valuable economic resource in the world. Therefore, the creation process is critical. So you need engineering process to create that. See here, this is one example, a software failure. If you got to know, there was some news. Boeing 73 Max, some flights fall down that due to a software error. Right? They are thinking that is a software error, software issue. So if something wrong in a medicine, maybe if you are a doctor, if something went wrong, the particular patient might die. But what happens if a software is providing wrong information? It's not just affecting one person, right? It's affecting the society. Can you understand the criticality of this now? I just want to show you the gravity, the criticality, gravity of this. That is why we need software engineering, right? That is why we need software engineering, and that has a carefully crafted approach, right? So it is a set of team. It's not a single individual. It's not an individual. So you need to. We need a team with skilled team with tools to build a software. So what is the process? The process is called SDLC, or Software Development Life Cycle. Anything in the world, I think now. So what's your age, Pute?
I'm 14.
14. Okay. Have you identified anything in the world has a cycle? Water cycle. So water that we are drinking today, it's billion years old. It's the same water that drunk by dinosaurs, right? But it is recycling. It is recycling. The entire world is recycling. So that is always happening. It's a cyclic process. Carbon cycle. If you're doing science in your school, you might know about carbon cycle. That is recycling, right? That is recycling, carbon cycle. So that is how we get food, right? But this food will be, again, going to the soil as wastage and different other ways. And it will again become nutrition to these trees. And when we eat trees, or maybe when we eat some other food like flesh from an animal, it will come back to us. Anyway, it's cycling. It is cycling. Anything in the world is a cycle, right? Anything in the world, even so, we have a cycle. After we born, one day we will die, but that is not the end. So again, we will reborn, and the same process will be repeated. right? So that is the situation. So anyway, anything in the world is a cycle. So only thing is we cannot see the time duration. That for some cycles we cannot see. The world will be totally destroyed one day, but it will begin again. But only thing is we don't know when, right? But anyway, anything has a cycle. So similarly, software has a cycle. Okay, let's say, so how, like in the end, like ancient time, how people build roads? Is it carpet roads like that you see today? Was it like that? No. So there was some like stone, maybe like it was only just footpaths in the earlier days. But after building this, after doing this, right? Maybe so initial problem. Why people build roads actually? Do you know why that has happened in the initial stage?
No.
Okay, there were some tribes, tribes, neither tribes. Is there tribes in America?
There used to be.
But not now.
Not now.
Some islands, maybe the nearby islands. No.
Maybe.
Maybe, right? Okay. Anyway, these tribes, they are like group of people just gathered, and for the survival, they were finding foods and nearby resources they were taking. And what actually primary needs of a set of people, or primary need of human being that time was just food, shelter, and producing their own generation, reproduction. Food, shelter, and reproduction. So that was the primary. Any animal, they need that food, a place to live, and they need children. So that is how they survive. The next generation is survived. Otherwise, that will be extinct. First it will become vulnerable, and after that, they will move away from the earth if they are not reproducing. So they need to maintain their tribe, right? So that is basic. That was basic. But the thing is, when the counts were drawing, the resources were limited. So they need to move away to find resources. That's why they need roads initially. That is wonderful, right? Not like today. So they need to find food. That is the main reason why they need ways to move away. Those are roads. Initially, the footpaths. So later, they have put some stones and they just made it comfortable. Right? Because time to time needs are changing. The initial need was food. The initial problem was food. The initial requirements need to move away, whether to go south or north. Likewise, they had to decide. Right? Then they have to find the best way, best alternative. Because they could imitate the animals that they see. Birds were flying that time. Birds were flying. And you can see reptiles. They're creeping. Fishes. They are swimming. Frogs jumping. And maybe monkeys. They are jumping from branch to branch in the tree. But still, or maybe hopping, whatever. So they have identified different methods of alternate ways of moving now. But ultimately they decide, no, this is not our method. We can't fly, we can't swim, we can't trade. Ultimately, they have decided, okay, let's walk. So all we need walking path. So that is the best alternative that they have chosen. So I'm trying to match this with the historical story, right? They need food. That is the problem. Need to move away. That is the requirement. How we are going to move? Are we going to fly? Are we going to die or fly? Or are we going to walk? Whatever. So they have selected, yes, we are going to walk. Then they have planned, which direction are we going to work? Are we going to work upwards or downwards or horizontally? Likewise, they were planning, and after that, they have implemented that plan. That is the actual footpath, road. And so actually it has to be tested by some elderly people or maybe some strong people in the tribe. Initially, kids and women, they can't risk their lives. They couldn't risk their lives. So initially, the strong people have tested that, and after that, deployed to the tribe. Then the entire tribe was using that. But time to time, there were some hiccups. Time to time, there were some issues, floods, maybe. Sometimes some trees fallen down. So they need to maintain that regularly. They need to maintain. Maintenance is needed. But after that, their younger generation, they started animal husbandry, right? The second tribe, the second generation. So first generation, they were hunters. Then agriculture and some other things began. So they need transportation mechanism, not just for food. They need to transport their goods, their animals. So the roads need to be much wider now because of the transportation need. And it should be comfortable enough. The footpath was not enough. So the second version of roads built such a way. And after that, the next generation, they were thinking about a comfortable way of moving. Right? Without getting their foods, maybe, and their dresses dirty, they want to move more comfortably. That is why this next version of roads built. Then there were traffic to address that. 2-lane, 3-lane roads, or maybe carpet roads for the comfortability. Then highways. In future, there will be airways sometimes, right? Because now, is there any personal drones like passenger drones still? The testing there are, but in future there will be, right?
Yeah.
Then there will be air police right? Police should be in air, right? Otherwise, like passenger drones, how you control the traffic? Traffic management should be done both in air and land. Air traffic control and land traffic control. So that is the next version of the world that we are imagining. Likewise, this is always, can you understand? This is always repeating. The same process is always repeating. Same is there for software. Okay, can you remember the oldest version of Windows that you have used? Have you used Windows?
Yeah, I have.
So what is the oldest version?
Windows is 64.
Yeah, it's 64. What is the oldest version? Like, is it Windows 7 or 8 or 8.1 or 10? So which version?
Oh, the one that I used last?
Yeah.
Oh, Windows 10.
Windows 10. First, have you used like Windows 7? Have you used? No.
No.
No, right.
I've used Windows 8.
Windows 8. Okay, 8.1.
Yeah.
Right. Okay. So that is like, if you ask from your father, right, he's like elder than me. So if you ask from, so I have used a version called DOS, Disk Operating System, DOS. So this is how I began. 1996, I started learning ICT. And my computer had this operating system, DOS. This operating system, it's totally CL, like command-based, right? Command line interface. So this is what I had. No mouse, right? No mouse, only the keyboard was working there. And there were like Excel-like programs. So that Excel was called Lotus 123. That was the Excel version that I learned in school in 1996. This happened, right? This is the Excel. So you can see this is not Excel, but this is the version of Excel that we learned in school. Can you see? It looks like Excel, right?
Yeah.
A, B, C, D, E, F, G, and 1, 2, 3, 4. This is the version of command line Excel that I learned in school, 1996. And then for Word, we had something called WP Word Perfect 5.1. WP 5.1. This is how Word looks like. Right? This is Word. Right? Then after that, I have used Windows 3.1. Windows 3.1. Okay, this was Windows 3.1. I have used this as well. So you can see now the initial version here. Let's map this to software engineering and software development lifecycle. So the first problem is using computer. CLI version began. So the feasibility study says you need something. That something has started planning, that something developed, that something was tested, and that is the initial dose that I have seen. But after some time, people thought we need colors, we need colorful thing, easy to use thing, convenient thing. So they came up with this version. This is Windows 3.1. That is bit easy, right? Bit easy because like it has colors, windows also. That is, and calculator. These are the initial program, clock calculator. Control panel was there, file manager. These were initial things, and picture gallery, small picture gallery, and this Minesweeper. That is one of the all games, most of all games that I see. Then this I have used. Then after that, not stop. And then actually in 97, I can remember Windows 95 came. But it came actually in 95. But Sri Lanka, it came around 96, 97, that period, end of that period. This was more decent than the earlier version of Windows 3.1. But still, there were some issues. For an example, when I play a movie in this version, it was not properly playing. It's playing like picture by picture mode, slideshow. It was looking like slideshow. If I play a small clip, it was like a slideshow. Then like we could see the frames are moving, frame by frame. So any animation will move frame by frame. For example, if I play a video, it is just set of pictures, right? If you have analyzed. So let me, when you go to YouTube and let's say you play some video, this is from my kid and let's play this. Okay, if I stop here, this is a picture. If I stop here, another picture. Right? If I stop again, another picture. Here, actually, this is set of pictures. So we call motion pictures. Set of moving pictures. Right? Video is nothing other than set of. So then, what is animation? Animation, is it set of pictures or set of drawings?
It's a set of pictures moving fast.
Yeah, that is also animation, but it is more. It is not actually a set of pictures. It is set of illustrations or drawings. It is not real, right?
Yeah.
It's not real. It's just drawing, imagination. But this is real. You have captured. But that imagination, have you captured using a camera? No, it is created. It is composed. So this one you can capture using a camera. But animation, you know animation, right?
Yeah.
Animation or cartoons, for example, just think about cartoon. Animation is not captured using a camera. Right? It is not captured using a camera. Here you can see. But it is just created, composed. Here, it is not captured, but it is composed. It's imagination. Anyway, whatever you saw this time was like this. It was not possible to play a continuous movie in that version very smoothly. But Windows 98 addressed that problem. That was smooth environment. Movies were good. Quality movies could be played in Windows 98. Then, not stopped, Windows Millennium Edition. I use this as well. Windows Me or Millennium Edition. That is for 2000. That is also before you born. And then came Windows XP. This is it. Windows XP. And after that, Windows Vista. This is Windows Vista. And Windows 7 came. Then Windows 8.1 came. 8 came actually. It was It has some errors, therefore 8.1 was much popular than 8. Then Windows 10 and now Windows 11. So see, it's a cycle. It's a cycle. It's going to end with Windows 11 or what is it?
No, it's going to keep on going.
No, it's not going to end. So there will be Windows 12, 13, likewise, there will be some more versions. Apple, iPhone 5, 6, 7, likewise it came. Right? Now we have 13, then 14, 15, likewise it will continue. Anything will be continued, like a cycle. Okay, then in your school, have you learned about these two tools? Flowchart and pseudocodes, have you learned?
I've learned about flowcharts, but I don't know pseudocode.
Right, okay, anyway.
Actually,
so these are some design tools, right? These are some design tools. Design tools means it is used in this step. Program design, system design step. Okay, just to know about the plan. How do we plan the system? Anyway, now we know the background. Now we know the background. How software begin, why software engineering is needed. So what is the process of engineering? And then actually each page I have explained, right? Each page, just you can go through these things are easy. Problem definition is where you identify the problem properly. Requirement analysis is where you identify the requirements needed. So what are the things needed to build this software? System requirement. Design is the phase where you plan. That is where you use flowcharts, pseudocodes, diagrams. That is like planning a house. For planning house, you need a house plan. No? House plan, is it a real thing or is it a diagram?
it's a diagram.
It's a diagram. So similar to that, the system plan or system development plan is a diagram. Right? Set of diagrams actually. It's flowcharts, pseudocodes, and set of diagrams. Then flowcharts, it has symbols. Right? It has symbols. I think you learn about these symbols. Is it same or different? Like maybe sometimes there might be slight differences. That's why. Same.
Yeah.
Right. So these are the symbols: start, process, input, output, decision, connector. And these symbols can be organized in 3 ways. There are 3 ways to organize these symbols. So the first way is, these are called control structures, ways of organizing a plan, a program plan. How? So what are the disciplines? What are the ways of organizing a program? Just sorry. So the plan or the program can be organized in 3 ways. One is selection, sequence. The second one selection. The third one repetition. Sequence is where instructions are executed one after another. Just give me example. Let me give you example. Let's say you are adding 2 numbers. Adding 2 numbers. That can be done this way, right? Adding 3 numbers. Start.
Yeah.
Input first 3 numbers. Finding the total. If you want, finding the average as well by dividing by 3. Display the total and average. So you can see it's flowing down as a waterfall. It's very clear. 1, 2, 3, 4, 5. Like several steps just falling down. Nothing to worry. So that is sequence. Selection. So what is selection? Selection means, okay, let's say you are at a junction. You are at a junction and can you turn all the directions and move? Are you doing that or you're selecting just one direction?
Selecting just one direction.
Only one direction, right? Yeah. Let's say you are in a junction and let's say you are going to school and you are in a junction like this. And then you are here and you have to select which direction to move. Are you going right or are you going left? Same time, you will not be able to go in right and left both. Either you can go right or left. Only one option. Right? That is selection. So there can be multiple options. But from these multiple options, you are selecting one instruction flow. based on a condition. So that is selection. So then sometimes we need to repeat tasks. For an example, going to school, we have to repeat until the school is over. Right? Until school is over, we have to follow the same path going to the school. And let's say then this is you and this is your school. Until the school is over, you have to go and come back one time. Next day also. You have to repeat this until you finish schooling. So that is repetition, following the same instruction path again and again until a condition. Repeat based on a condition. So that is repetition. So these are three important things. Right? Have you learned this or not?
No, I haven't learned this.
You haven't. Okay, anyway, instructions can be repeated, sequential order. That is called sequence, one after another. Instructions can be executed based on a condition. A specific flow can be selected. That is selection. So when you're going to repeat the thing, that is repetition. Okay, since we have discussed more theories, I will give you small trigger to a practical and finish today's one. Otherwise, like you will feel bored because we have discussed a lot of theories. But anyway, the thing is, you need this set of theories. That is the foundation, right? But hereafter, so you have some coding. Okay, so let's code for this one. Let's code for this plan first. Okay, you can see this plan. Start, input N1 into N3, total, find in average. Average is, the median value of all three. Display total and average and finish. Okay, let's code for that. We have to learn some more theories about variables, about identifiers, but I'll keep it for the next day, since otherwise if you're going to learn everything within one day, you feel boring. Okay, so let's take your IDLE. Can you? Just take your IDLE, the installed software, Python shell.
Yes.
Okay, then take a new file. As I said earlier, take a new file. So that will be empty document like this. Okay, then start. Actually, we are not going to mention anything about start, but input you need to mention. We can say N1 without any space. You have to tell N1 equal input. This is how you take input. So very easy, right? Very, very easy. Input, then you have to give a message to the user. Enter number 1. Okay. Repeat the same for the second number and third number. Just copy and paste. Change these to number 2 and number 3. We have taken the input. Then total, you can say total equal number 1, number 2, number 3. Just add them. So very, very simple. Actually, pseudocode looks like something like this, but still we didn't study pseudocode. Let's do that next day. Pseudocode is also a part of planning. I'll teach that next day, don't worry. So just write this code for the movement. Then display the total, print. You can say total is the total that you have used. So be concerned about this capital simple letters that you're using here. You have to use same. Okay.
Okay.
So let's save and run. That's it. File, save as. Mac is much similar to Linux, but there are some basic differences, but commands and all, the way that you are saving and all. So there is much, it's similar. Let's save as, let's say day 1. let's say June 15. So I'm giving meaningful name, then I can just send you as all the files I can send you after the lesson. That's why I'm just giving a meaningful name. You can give any name that you like, doesn't matter. PY is the extension for Python. Even you give this or not, it will take this extension, right? We can mention this or we can ignore this. If you ignore, automatically this extension will be assigned. If you mention, it will be taken. Just save it. And run it, run module. Then it will ask, enter number 1 and stop. You have to put some number, press enter, then ask in the second number. Put some value, press enter. Ask in the third number, some value, press enter, and you'll be getting the answer. But the answer is something weird, like this.
Okay.
Are you getting the same kind of answer?
Yes.
It's not addition, right?
No.
It's not just truly addition. It has concatenated. Just merge them together. It's not added. This is good for adding like first name to the last name and generating full name. So this will be good, right? But this is not good for adding numbers. Since you have to mention this is a number, you have to mention that explicitly. Okay, I have done this to show you the issue. If you want to tell that, if you want to show that this is a number, then you have to go here and add something called int to tell that this is integer, a whole number, and bracket it. Int, open the bracket, then go to the end, close the bracket. Int, open the bracket, go to the end, close the brackets. Save it, run it again. This time we'll be getting the accurate answer. Can you try?
Okay. So
if you're getting any error, please let me know. You can share the screen. I can help you.
Okay.
You're getting the answer?
I am typing it in.
Right now. Just take your time.
Okay.
In case if you're getting any error, you can share the screen. Doesn't matter. Then I can help you.
Okay, I got it.
Right. Are you getting the answer?
Yeah, I got it.
Okay. Just share it, Nilanjana, then I can just see. So.
Okay. Let's see. Are you?
Yeah, that is it. That is correct answer. Good. Okay, so is it difficult or easy? What do you think?
It's pretty easy.
Yeah, it's easy. Right. The thing is, like, when the logic is complex, only it's getting complex. But the thing is, like, syntax coding is not difficult, right? It's easy. It's very, very easy. So when you type in Java, so I can show you the same steps in Java, right? If you like, I can show you. But the thing is, it is bit difficult and need some more coding than this. Just to compare, I'll show you, right? But don't worry, don't be upset. Otherwise, you will think, this is going to be difficult. No, not to do that. Actually, I just want to show you how it is implemented in Java, right? That is why I'm going to use. I'm using editor called brackets. That editor is available in Linux also. And then again, let me take a new file new. Okay. File new, so I'm taking a new file. In Java, you have to do something like this. Since you have to go like get inputs, you can say class hello. Actually, Java is different version, different way, because it is something called double OP, object oriented programming. Then you have to say public static void main string. See, public static void main string of system dot out dot print, and say enter enter number 1. Then you have to say these variables also, int n1, n2, and n3. Let's print all these three, and reading part let's do next. 2, 3, THRE. No need to try this now, just look. So no need to try this now because it is like a bit difficult. So I'll tell you, right, after finishing Python, we can move into Java and then we can practice.
Okay.
Right. For the moment, just see how it is done. Okay, then so let's save this for the moment and see. Documents, same name, hello, Java. Something like this. Okay. Just hello world. Okay, this is using Java GUI, right? So this is using Java GUI. I'm going to show the same thing like this. You have to use something like this. You can see the coding for same thing, finding 3 numbers, and then the total. CLI also you can use system inputs, but just that is even you need more coding for that. So this is what you are doing in Java for the same task. You can see it is bit more coding. And the capital simple you have to remember, but the structure, just refer the structure. If you refer to the structure, it's like looks same, right? Looks same.
Yeah.
Here, 3 numbers, find in the total, but only thing is like there are types like INT, how you mentioned. That is why I say, so if you learn one programming language, it's easy to adapt to the other. But if you try to learn this first, you will feel programming as a difficult task. That is why I said that I'll teach Python first, then we'll move to the Java slowly. Because once you learn this, learning this will be not difficult. But if you try to learn this, you will feel difficult. That's the reason, right? So don't worry, I'll be teaching that also. But for the moment, so let's learn Python carefully. Right. So actually, today's note I'll be send. Is it okay to send you email?
Yeah.
Right, I'll send. And here you can see this is a Java code is also there. So this using util scanner class, you can see this is Java code. It is also there, right? But here this is using the swing that I just showed, Java GUI, graphical user, and this is the Java command line. All codes are there, but if you like, you can practice. If not, just trying this is enough. Just trying this is enough, and this is how you find the average, right? This is how you find the average in Python. Just divide it by 3 and print it. So very simple. So this part I will be sending you, right? So shall I send up to this Java? Is it okay?
Yeah.
Right. I'll send up to this, and I'll remove the singular medium part. Otherwise, you will confuse. And I'll send it to you. Then when we are going to have, like when you're going to have the next class? So do you have any idea? Is it next week or tomorrow also?
I don't know yet.
Right. Okay.
I've heard.
Yeah, talk with your parents and let me know, right? Talk with your parents. You can just drop me a message through Facebook or email. Then I can schedule accordingly. Okay.
Okay.
Is there any difficult point that we discussed today? So is there anything that you need to re-clarify?
No.
No. Okay, good. So have you enjoyed or is it boring? Sure.
Oh, it seems interesting.
All right. Okay, thank you. Right. Anyway, so let's see you next day. Then good night. Bye.
Thank you. Bye.